So welcome to East Academia. My name is Brian, and today we are going to talk about some common types of equations or identities that we are going to use in Calculus 1 and even in Calculus 2, 3, 4, and 5, and any mathematics course or any algebra course, you usually use these types of identities. Now, the first identities, and we are going to be doing them using, and you're going to have a proof for them, is that a squared, no, is that, let me just say a plus b squared, okay, and you're going to prove is equals to a squared plus b squared plus 2ab, all right? So in most cases, when you come across a situation whereby you're squaring a plus b squared, definitely you're going to know that it's going to come with this one. So this is an identity that you can always have. It's not a must you be deriving it all the time. Now, if you want to prove, you can just take a plus b, that is how it looks. And then you take a into a plus b into a plus b. Okay, you're going to get a squared plus ab plus ba plus b squared, and this is one and the same thing, yeah? So because ba is the same as ab because it's a product, yeah? So you can sum them up and have 2ab plus b squared, which of course you can just rearrange a squared plus b squared plus 2ab. All right. So an example is if you are given a question and you are told to evaluate a x plus 4 squared. So what is x plus 4 squared? You can just directly use this one here that we've derived. So a squared, so it's going to be x squared plus b squared. So of course this is the a, this is the b, plus b squared, which is 16, plus 2ab, so plus 2 times a times x times b, which is 4. So my answer is going to be x squared plus 16 plus 8x, which of course I can write it as x squared plus 8x plus 16. So you really don't have to open the brackets and all that. You can use these identities. So that is an example. And then the next one, you are going to have one for subtraction. And this one basically is a minus b squared, all right? So to me, it looks like the first one. Instead that you are going to have a negative sign in this case here, all right? So it's going to be a squared plus b squared minus 2ab. So something of that kind. So how do we prove that this is the case? So to prove that this is true, we are going to have a minus b multiplied by a minus b. Then if we open the brackets, you're going to get a minus b, okay, minus b, a minus b. And we proceed. You're going to get a squared minus ab minus ba plus b squared, because minus b times minus b, you're going to get a positive b. So I can rearrange this one to a squared plus b squared minus 2ab. So I've already proven that that is the case. So then, in any case, if you're told to evaluate x minus 4 squared, you say that this is a minus b, isn't it, squared. So you can easily get the answer as a squared, which is x squared, plus b squared, which is 16, isn't it, minus 2ab, so minus 2 times a, which is x, and 4, isn't it, times 4. So the answer is going to be x squared plus 16 minus 8x. So in this case, it's going to be x squared minus 8x plus 16. So that is the answer. And then now we have what is known as a difference of okay, this is what is known as the difference of two squares, okay? Difference of two squares. No, this is not the difference of two squares. Let me come to difference of two squares. this is a product of two differences, because you can see you are multiplying a minus b and a minus b. So then now we can come to what is known as now the difference of two squares. Now if you have a plus b and you are told to multiply with a minus b, let us see what we are going to get in this case. All right, so let us just open the brackets. So we are going to get a minus b plus b, a minus b. All right, and here we're going to get a squared minus ab plus ba plus ba minus b squared, and these will cancel out. So I'm going to get a squared minus b squared. So this is a difference of two squares. So a plus b, a minus b, when you get the product, you are going to get a difference of what? Of two squares, which is a squared minus b squared. And this is what we covered. So in essence, if you are told to evaluate x minus 4 and x plus 4, then you can be sure that the answer will be x squared minus 16. And I think we did this in our first video. So in this video, I just wanted us to get introduced to these identities, because we shall actually use them in a very great deal. So another thing that I would like us to note is that if you are given something like x squared minus 9, by just looking at it, you are going to know that this is a difference of two squares, okay? Because this one can be written as x squared minus 3 squared, isn't it? So of course, if you are looking to factorize this one, you don't have to really work around your head, isn't it? You can just know that it is x plus 3, x minus 3. So I want you to be able to look at an equation and notice that this is a difference of two squares, and I can factorize it in a certain way. All right, so just try to factorize this one, and then so factorize, let me say x squared minus 25. So pause the video and evaluate it, and then we do it together. So okay, thank you. So thank you for trying. So this one, again, this is a difference of two squares, because it can be written as x squared minus 5 squared. And so as we said, a squared minus b squared is the same as a plus b, a minus b. All right, so in this case, you are going to have our answer as x plus 5, x minus 5. And that is the answer that you're going to get. So that is how you are supposed to proceed under these situations. And thank you for watching Mr. Academia, and have a nice time.